Hello, and this is the lesson on coefficient of determination. So the coefficient of determination is r squared. In a previous lesson, we already worked out r, and r squared is just that value squared, but our calculator will find it for us. So here's an example that we'll use to go through and see what r squared actually tells us about this information. So at a father-son camp, the heights of the fathers and their sons were measured. So they've all been listed in this table below. And it says to draw a scatter plot for the data, calculate r squared and interpret its value. So we're going to move on and enter this data into our calculator so that it knows the data in the table. The top one will be list 1 and the sun's height on the bottom will be list 2. So we press stat, which is here. We press stat on the calculator and up will come this screen. We just press enter so that as long as edit is selected, it will allow us to edit the list and put this information in. So stat, then enter. This is list 1 and this is list 2. It's best to do it in that order. And I enter list 1 and then once I've done that, I press the right arrow key and then I enter list 2. So list 1 being the father's heights, 175, 183, 170 and so on. And then in list 2, we've got the sun's height, so 167, 180, etc. So I'll press stat again, and I press the right arrow, and I select calc. And I go down, and r will be with r squared in the linear regression ax plus b. So all of this data will be in the linear regression ax plus b. So I'll go down to number 4, and I press enter. And up will come the following screen. Just make sure that you've got list 1 and list 2 listed here, and everything else is blank. Go down to calculate, and that will tell you r squared. Some of you were getting this screen, so if you've done that correctly, you'll get r and r squared below. But if you haven't got r or r squared, and it's just giving you a and b, which is not the answer, then we need to press the second button, and then we need to press 0. And what that will do, the second button gives us the blue option, so catalogue, and it will come a screen. We scroll down to diagnostic on, and we press enter twice. So you need to press enter twice for that to work. If you do that, then what it's going to do is when you run through the linear regression screen again and get to this page, you're going to actually get the values of r and r squared if you couldn't see them. So you only do the second catalogue if you couldn't see the values here. So you should be able to see r squared if you've done it correctly. So it's 0.683236255. So you'll be able to see r and r squared if you couldn't before by following those instructions on the previous slide. So we've got an r squared that's about, I've done rounding, I didn't write all of these decimals, I just write the first 3 decimal places. So 683, and then the 2 didn't round it up, so just 683. And what is r squared then? What does that tell us about the data? Well, it's the degree, it's how much the independent variable explains the change in the dependent variable. So how much did the father's height affect the son? Does having a tall father mean that you're going to have a tall son? So that's what that is telling us, it's what extent. And it's actually a percentage, so we can actually have this sort of stock standard answer here that we can fill in every single time we're asked what the value of r squared means. So currently it's 0.683. We multiply that by 100 to get it as a percentage. So we get 68.3 if we multiply that by 100. So 68.3 of the variation in the son's height can be explained by the variation in the father's height. And it's always this way around. So I've just put in brackets here y, which is here. So it's the son's height. You don't need to write the y in brackets. That's just for your notes. So you know that the variation in the y value is caused by the variation in the x value. So it's always that way around. The dependent variable and the independent variable in that order, okay? So here's another example where we're not told x and y, we just have to figure out which causes which. So it says from an investigation at an aquatic centre, the coefficient of determination between the variables, the number of visitors, and the maximum temperature is found to be 0.578. Complete the following interpretation of the coefficient of determination. And they want you to fill in the blanks. So you'd expect that the number of people that attend will be dependent on the temperature. The temperature doesn't depend on how many people go to an aquatic centre. If it's very, very hot, then people won't go. And if it's very, very cold, people might not go. It might sort of be in the middle. So the temperature will affect the number of visitors. So our coefficient of determination is 0.578, which is here. We're going to multiply that by 100 to get 57.8. So 57.8% of the variation in something can be explained by the variation in something else. So what will be explained by the other one? Well, we just said that the number of visitors will be explained by the temperature. The temperature causes the visitors, so therefore the number of visitors can be explained by the variation in the temperature. We want it that way around. So always going to be the maximum temperature is the number of visitors is dependent on the maximum temperature, so the dependent variable and the independent variable below. So here's a different example. For a group of children, the correlation coefficient, negative 0.365, is found between the variables heart rate and age. Find the coefficient of determination and interpret its meaning. So remember, we've got two different things. Correlation coefficient is R. Coefficient of determination is R squared. So they're very, very similar sounding. The top one is R. We want to find R squared. So we've got R is negative 0.365. And we just square that on our calculator, times it by itself. And you should get 0.133. So you're always going to get a positive value for R squared, because when you have a negative times itself, it's going to cancel out and become positive. So you're always going to get a positive R squared. So its meaning is we're going to take our stock standard phrase and we're going to multiply this by 100 to get it as a percentage. So 13.3% of the variation in something can be explained by the variation in something else. So which one do we think causes what? Does the heart rate affect what age you are, or does your age affect your heart rate? So age will affect the heart rate. You can't change how old you are, but that will affect your heart rate. So the variation in the heart rate can be explained by the variation in age. Again, the dependent variable on top, the independent variable below it. And make sure that you're using R squared here, not R. So only the R squared value goes in here. So here's an example that Joanne is a real estate agent, and the table here shows the distance from the city for each house and the selling price. So here's the scatter plot. We can find that just by plotting each of these points. Just in terms of making a scale on this one, the lowest value for distance from the city in this top row is 4. And the highest value is 35. So it makes sense just to go from 0 all the way through to the biggest 10 after 35, which is 40. So we've gone from 0 all the way through to 40. So you just take the biggest 10 after 35 and the lowest 10 below 4, which is 0 and 40. And then the selling price, the smallest here is 260 and the largest is 540. So the smallest one being 260, if you round that down, even though it's 60, round it down and we'll get 200. So we can start at 200. And 550, well, the 100 that comes after 540, is 600. So we want to go somewhere between 200 and 600. So we can use this zigzag line here to show that we're skipping some numbers and starting at 200. That's how you show that with the zigzag line. So just make sure you've got a good scale, otherwise you won't see the points well. With the scatter plots, you always want the points nicely spread throughout the whole page. You don't want them all clustered in one area. You want them all spread out. Just remember to label your axes, distance from city and selling price. So now we just need to enter this information, like before, as list 1 and list 2. into our calculator, and it will tell us R squared for part B. So if you do that correctly, enter list 1 and list 2. Just make sure that when you've entered it, that at the very bottom, there are no zeros or no other numbers. Make sure if there are numbers, so my last one is 12 and 350. Here, 12 and 350, there's no more data. Just make sure you delete any extra data with the delete key, which is here, the delete key. Make sure there are no zeros or any other numbers, otherwise your answer will be wrong. And list 1 obviously should be the same length as list 2, so they both finish on the same row. So if I go to stat calc and then number 4, which is the linreg, up comes this screen and my R squared value is here. So 0.561, because that 9 will round the 0 up to a 1. So we can take our normal phrase, 56.1% of variation in the selling price can be explained by the variation in the distance from the city. So we times that by 100 to get 56.1, and its variation in selling price, which is the bottom one, can be explained by the variation in the top one. Part D, it says, what other factors could explain the variation? So you could have the age of the homes. We don't know the age of the homes. In certain suburbs nearer the city, you might have more modern homes. And within each suburb, you might have different facilities. So it might be that there's a train station nearby that increases or decreases the value of the homes. Or it might be that there's a nice shopping centre that also has increased the value of the homes. So things like that you want to say.